Alright, I think we're set. Alright, I think we're set now, so what we're gonna do today, remember last time we ended off writing the logic for the binary files, taking in binary files for our program. So today we're probably going to be doing a Fibonacci program, which is what Claude suggests. So let's see what we have to do. Let me turn this down a little bit. Alright, okay. So an iterative Fibonacci, each of registers and a loop, much simpler, okay. So compute Fibonacci 10, setting x1 equal to a, so setting x1 as that value is x2, starts at 1, the loop counter will be x3, x4s are temporary. So add I, so loading the value of 0 plus the register, so into a, so a is gonna essentially be 0, the value 1 into register x2, so that's b. Our counter is equal to 10. Counter is equal to 10, so our I will be, so we're loading it to x3. Then a loop, so we're adding x4, x1, x2, so we're adding the values of x1 and x2 registers, storing that in x4, so that essentially means temp equals a plus b, as you see here. Then add instruction, the register value here plus this register value, and store that into a, so now a will be equal to b, b will be equal to 10 for the next one, I see, okay. Okay, wait, so a is b, okay, so then b is tab, okay. Counter minus minus. And branch if not equal to x3 and x0 if they're, if our loop counter is not equal to 0, then we go back to loop. So essentially this will keep running until the counter hits 0, and then e-break. Oh. So wait, so actually, let's try to see. So A will essentially become B every single time, right? So then B, and then B becomes the value added together. So in this case, 1, 1, A will now be 0, B will be 1. This is the next iteration, 0. It will be 0, B will be 1, so then it will just be 1, 1. So then A will be 1, and B will be 1. Then the next iteration, 1, 1, so 2. A will be 1 again, but B will now be 2. And we move back to 1, 2, so 3. A will now be 2, B will be 3. Okay, so it's just gonna keep moving up until the counter goes down, like that. And I think that's right. Yeah, so essentially what I got, yeah. But okay, yeah, that makes sense. It ramps up pretty quickly, so essentially, yeah. So this keeps going on, but it ramps up much more quickly than I thought it would. So, because I was wondering, like, it said 55, like, we were on, what, the 4th iteration, and we were on, like, 3rd iteration, we were on, like, 2 and 3, so I was like, okay. But yeah, that, I see why it ramps up fast from here, yeah. I see. So, for something like this, we don't really have the... We have logic so far for a binary, but we don't really have the way to just straight up write instructions automatically. Oh yeah, my bad guys. 1 second, I just realized I hate to change the day count. I have it on 8, but we're actually on 9. Let me change that real quick and we'll continue back. Real quick, YouTube Studio. Stay 8 here, yeah, you change it. Okay. Day, yeah, we're actually on day 9. Okay, that's better. Change. Yeah, okay, changed. Alright, let's get back to the actual stuff now. Alright, we're back now, and alright, so we don't actually have any way to actually do like assembly itself. Right? So I guess we can start implementing something at least. I'll just write something. Let's write something, a little something down here. Or we can write it in main. So we can do like a number choice. So if choice is 4, we can start our memory. Just like usual, we just instantiate our variables and our structs. So core. Okay, so I guess for now we can just hard code it for now, because there's no way of really, we don't have like the means to actually do that. I think we could try implementing that later, but let's at least try and do a simple implementation. So I think we could store values inside a vector and try and implement something here for, let's just call it like fit program. And So we need to get all like the instructions, right? We need to get all the instructions. So we'd actually need to know. Let's see. Assembly to hex. risc-v hexadecimal, nice. Okay, so our first instruction was add x1, x0. x00, okay. Oh, is it not going to give us the value? Oh, no, it is. Okay. It's just showing us the breakdown, which I already know. I just don't want to compute myself. Oh. Wait, my bad. x1, x0. Yeah. So that's hex 0x03. So same thing for the others, we can just implement. It's quick. We're gonna have to store it like this. So like that, at x2 0 1. That would be our next instruction. So now we have add I x3 x0 10. I x3 x0 10. It's same, just get the value. So that would be that value. And next value will be, now we're starting the loop, so add I x4, x1, x2. I think I'll just copy. Yeah, I don't want to write it. This will be easier to copy. Alright, so we have this value now. I'm gonna take this value and x value, this value. Then we have the next value. Okay. Add I. Just 2 more instructions left, guys. And I did it wrong somehow. Is it not? Are we not able to do that? x3 minus 1. Let's go as chat. Let's try to. Let's do it. I mean, not risc-v. I meant risc-v. Hex, my bad. I meant hex. Okay, there we go. Okay, what's next? RBNE loop. I mean, like, can you just say it like that? Because when it say error, so how do we get it to loop back? And hex, how do we get it to back to? Yeah. I just minus current PC. So, okay, alright. So this just need to like branch back to the Hey, what's up, Code with Syria? What's up, man? Alright, so I just need to find a way to get back to them. I think for now, I just want to skip that for a second. Let's, okay, wait, the e-brake. I'm just living here in the States, United States. Oh, okay, I'll just get the e-brake. Nah, sorry, man. I can't give you mod. Okay, I'm just gonna write this here. I need the other one here. That should be it for that part. I mean, you're new to the stream, so I don't really like know you that much, so that's why I can't give you mod. Alright, so now we need to figure out how to get that other instruction. So I guess program counter would start at 0 here. And I just keep incrementing up by 4 for the program counter. So we had 12 here. So we want to loop back to 12, the program counter to 12. And this one would be at 24, right? So no, we're going for this one, my bad. So 28. So okay, so we need to be -16 bytes, right? And we need to get that in. Let's write it down real quick. So we need to get that to binary and then convert it to hex. Let's do that real quick. So binary value is I don't know if it's that simple. I think I'll ask Claude. Having difficulty here. So I'm hard coding these values. So because we have no way to having difficulty with getting any instruction. Let's see what Claude says. Yeah, that's what I got, like the immediate -16. You need to bridge back to 16. Oh, but I guess we do need to get the rest. Right. So I guess that bit 31, so the immediate would be, that would just be 1 there. It's 10 to 5, like from a 4. I guess it's just the full amount of 1s, right? And after that, I'm pretty sure it's a break between that, so it'd be RS2, if I remember right. RS2, RS1. So our RS2, right, it's x0, so it's just gonna be all zeros. And for x3, so it's just gonna be 3, which should be 1, 1. But we need 5 digits, so it'd be 0, 0, 0, 1, 1. Okay, wait, let's actually write this down. Okay, so 1 for the bits, those 6 bits, so 1, 2, 3, 4, 5, 6. RS2, so, and then, okay, for RS1, and Funk 3 for B and E. It says right there it's 1, so it's just gonna be 0, 0, 1. And then that's when I believe you add back in the immediates, because opcode is always gonna be at the bottom, so it's gonna be the immediate 4 to 1, but it's 4 to 1, so in that case, so okay, wait, so we have 5 bits, so I see. Okay, okay, I got it. Yeah, I got it. So it's just gonna be 1, 0, 0, 0, and then the final bit is 1. Then our opcode is 0x63, which I don't know off the top of my head, so we're gonna have to go check. For B&E, right? B&E 1100011. So this should be it. Should be our final binary, and we get this value. So yeah. Okay, I kind of got it at the beginning. I just wasn't sure. So that's just the immediate value. We have to always make sure that we assemble it back at the end. So that's a good thing for this thing that we did right now. So for the next time, we will know to actually assemble it back. Okay, so now I think we have all the instructions included. This should be e-break, right? Yeah. So okay, so now it's just like getting the instruction out. So essentially, just setting it up like how we used to do. Setting up our address. Just as usual. Well, I guess it'd probably be better to do unsigned because address never really goes to 0. So I'm gonna change this to over here. Okay, so just initialize it. And since we're doing Fibonacci, so we need to do the for loop, because that's what we need. And it'd be the instruction, right? And we can just do this one like this, just like how we have it for our Fibonacci program. So it would kind of just be like that. So instead of shading this, so each instruction would go, it would go through, right? essentially just writing to the memory, like we usually do, and then running the core at the end. Well, we have to first do the address, and increments by 4, and then do whatever, just like how we usually do. Well, this is a different case. Yeah, usually we just have this like this, right? So that makes sense. And in the case for this, what else do we need? So we have that. Okay, I'm not gonna waste chat because we already know. Okay, so I guess just printing out the register state as we usually do, right? I guess this is good. Let's test it out real quick. Oh, right. Let me just go in here and quit. We need to instantiate it. I totally forgot. Not instantiate, but like get the setup right. So. Here. 4, and this would call it Fibonacci program. Slash n. Slash is on this side of the keyboard. Okay. So up here. Alright. I'm still getting used to this new keyboard. Alright, so now that we have that, right? So I need this. So we're not really inputting anything, it's just testing out. So now we have the Fibonacci program. So yeah, let's see our end result. So right here it says that we need A to be able to, the A would be 55, so that means x1 is 55. Our B value, which is x2, should be 89, right? Our temporary in x4 should be 89. And yeah, it looks to be right. Looks like we got the actual Fibonacci program running good here. I think, yeah, that's actually pretty good for now. But this is only hard-coded. We need to actually see what we can do to improve it. Seems to work out. I guess this is good for testing out, because in order to get like real values, let's see what Claude says. How long have we been streaming for? Not bad, 35 minutes, not bad. So we text machine code, essentially writing an assembler. that would be hard. So I guess yeah, .bin files is probably the right path. Yeah, writing an assembler would take too long. I mean, yeah, not a bad future project though. That's a future project, but I just don't think I could do that right now. Not even gonna lie. There's just so much I have to learn about so much more I have to learn about assembly to get to that. But yeah, I guess the 2chan approach with the .bin file would probably be better. I think for commit ABI won't hard. Be right back, guys. Alright, back, guys. Sorry about that. Let me just get the stuff back on. Alright, we're back. Okay, so I think maybe I'll probably try and actually implement it properly without it being like a whole hard-coded thing. We can give it a shot. Essentially, it'll be the same core model, I'm pretty sure, and then just this time it'll be with bin files. I actually don't have the tool up yet, but I'm sure we can think of something when the time comes, and then we'll get it in. For now, I just want to write like the actual thing. Okay. So same thing as before, struct initialization. So, but in the case of this, we had it in a vector, right? So how would we do it for a bin file? I mean, I guess for a bin file, we wouldn't really need one because it'd all just be loaded in. Essentially just all be loaded in, right? So Alright, so let's load it in first, maybe. Load in the file. Essentially, we need the same exact logic in here. We need to load the program in. Okay. But now this is where it gets kind of weird. Since we're not actually doing that, right? We don't know exactly when to move back the instruction. So that's kind of annoying, dude. I don't want to keep asking Claude, bro. Like, I want to actually think about it. Like, it's not coming to me for these things sometimes. So that's kind of because like how do we know in the bin file when to actually go back? If there's a way like to do that, then I could be able to, but I just don't know how like the bin files actually work, which is the problem. Which I'll probably get more understanding as I go. But yeah, for now I just don't understand like how. Or wait, since it's automatically. Wait, yeah, no, I'm stupid, bro. Wait, I think I'm coming here, bro. We don't even need this, to be honest, bro. Because, like, if we think about it, all these instructions that they're going will already be in the bin file itself. So when it hits something like this, we don't have to program it like to do that. It'll automatically do that. So yeah, what am I thinking, dude? We don't even need this stuff. It'll do it automatically depending on who like sets the bin file. So we don't need this part, but yeah, I guess we don't even need any of this part. It'll just do it by itself. It's essentially just, I mean, it's essentially just that program. It's the same, right? Wait, yeah, so we wouldn't even need that, right? Must be tripping, bro. Wait. Yeah, it's just raw bite, so. Okay, so I'll just commit that code just for the sake of it. I won't actually keep it, but just to show that I have actually done something like this properly. And let's just check it again. Yeah. Okay. I'm actually glad that we didn't need to consult Claude for that, bro. Before, I somehow like thought of it like right as we were about to send this. I was like, wait a second, we don't need to load it because it already has encoded in there. So yeah, that makes sense. That makes sense to me. But what else do we need to do? Cloud will install it very, very soon. Trust me. Trust me. But yeah. I mean, we technically already completed phase 1 last time, but we were just, we were just doing the Fibonacci thing. What's for the next part? Let me go check my GitHub real quick. Okay. Alright, so that part's alright, so negative info produced by the tool chain and run it through your emulator. I see. Okay, so what's the next step? Okay. I mean, he's not wrong. I did see that starting to get to a point where like I'm losing my touch a little bit. At the beginning, it was running smoothly. Now, I mean, it's still running smoothly, but like I could notice it was getting significantly harder. So if I go into something like this, I mean, for what we've covered up to now, I know about it, but for this, I don't know what that is, and I don't like I know this like a little bit, like just a concept, but I actually don't know how it works, so I can't do anything with that. So I mean, I guess for now we can just end the stream. I'll continue reading the book. I'll try to finish that. I'm still working on it, but I guess in the meantime for streams, I guess we'll try to find something to do. We can just keep practicing and stuff, you know. But yeah, I'll see you guys next.